Hello all, in this particular tutorial, we will go through RMAN theory and concepts which will help you to answer RMAN related questions in your Oracle DBA interview. Now, if you have not subscribed to my channel, do subscribe to my channel. Before I proceed, let me give you a hint. Here, I would not be asking a question and give you an answer. Rather, we will go through all the concepts related to RMAN, and these concepts can be a potential question. So, I'll be explaining you the concept, and these concepts will help you to prepare for your RMAN interview. Let's begin. So, what's RMAN? So, RMAN is an Oracle utility that automates backup and recovery operations. It performs tasks like backup, full or incremental, recovery, complete or incomplete, cloning the databases, reporting on backup status, validation of backups. There are so many other things that it can do. As and when we go through this particular slide, you will come to know what are the other things that RMAN can do for us. RMAN integrates with Oracle database and ensures consistency during backup without requiring the database to go offline. There are some types of backup which needs the Oracle database in the mount mode, however, never offline. What can be backed up? Below physical files can be backed up such as SP file, control file, data files, archive log. What is not backed up? P file, password file, log files, temp files belonging to temp tablespace. Oracle RMAN can back up SP file but not P file. So this is yet another reason why you should run your database using SP file but and not P file. Now, how to connect to RMAN? You set the Oracle environment using aura env and you can run the RMAN command. So aura env, which will set the environment, and you can say RMAN target slash. Whatever is the current Oracle SID, your RMAN will get connected to that Oracle SID. And if you don't want to do that, you can say, first you can say RMAN and then you can say connect target slash. Both of these commands will do exactly same. Other option is you can, if you have a remote database, you can say RMAN target sys at target db, which will prompt you for the password, or you can say RMAN target. You can give the password in the same line, RMAN target sys / password at target db, and same things you can do using the RMAN prompt. So let's see this. So let's launch here. Let's exit and let's clear. And first thing that we will do is we'll set the environmental variable. Then if I say RMAN target slash, I'll be connecting to the database called aura19d. And the reason why I got connected to aura19d is because my environment is set to that particular database. Now, I could also do something like this. I can just launch RMAN and then, I can just launch RMAN and I can say connect target slash, and that will also connect me to the same database called aura19d, which we connected here. So that's how you invoke the RMAN. Now let's proceed. The types of RMAN backups there are broadly there are full backup and incremental backup. Backs up all used blocks in the files. Incremental backup is the equivalent to full backup, so it's same like full backup. However, it can participate in the incremental strategy. Level 1 backup is a backs up only blocks changed since the last level 0 or level 1 backup. So differential is the one which changes whatever blocks which are changed since the last level 0 or level 1, and cumulative will capture all the changes since the last level 0. So remember, this is very confusing. So differential means, let's say you have taken a level 0 backup, then you took the another level 1 backup, and that level 1 backup will now check what are the differences between level 0 and level 1, and it will capture both all the changes that happened between this. Let's say you take another level 1 backup, it will not go back to level 0. If it is a differential, it will not go back to level 0. It will check what difference happened between level 1 and the new backup. However, the cumulative will always refer to level 0. So even if you have taken a differential backup, level 1 differential backup, it will not take that into consideration and it will always go back to level 0. So cumulative is the changes since last level 0 regardless of any indemnity. So even if you have taken any level 1, it will ignore those backups in the cumulative. Now there is a detailed answer. This is a broad level answer. There is a detailed answer for this question, and the detailed answer is what kind of RMAN backups. So you can have full backups, you can have incremental backups, level 0, level 1, differential and cumulative. You can have image copy backups, you can have backup set backups, you can have tablespace level backups, you can have data file level backups, you can have control file backups, you can have SP file backup, you can have archive log backup. So these are the different types of RMAN backups. Let's see all of these backups one by one and the associated commands with that. So if you want to take the full backup, this command creates a full backup of all data files in the database. You will say backup database. And if you want to include the archive logs, you can say backup database plus archive log, which will take the backup of the database along with the archive log. Now backup database backs up all blocks of a file regardless of whether they have changed. So it will not check whether there is a incremental strategy, like whether if from the last backup, if you have taken the last backup, it will not check whether something changed. It will always take the backup of all the blocks of the file. Now, although it's a full backup, it cannot be used as a baseline for incremental backup. Although it's a full backup, it cannot be used as a baseline for incremental backup. This is very important. So if you take the backup of the database and if you try to take the level 1 backup, it will say that you don't have level 0 backup, and it will actually initiate a level 1 backup. It will initiate a level 0 backup. Remember, this gets confusing. So what I'm trying to say here is, let's say you took the full backup. So you using backup database, you took the full backup, and then you try to take the level 1 backup. Then this level 1 backup will not be a level 1 backup. It will be a level 0 backup. If there are compatibility levels, I don't want to get into all of these details, but what will happen is, like in the newer versions, the first level 1 backup, if the level 0 backup does not exist, it will convert it into level 0 backup, and then going forward it will take that as a level 1 backup. So remember that, and it will, even though this is a full backup, it cannot be considered as a baseline for the incremental backup. So this is very important. Now, you can also take the tablespace level and data file level backup. So you can say backup data file 1, or this will backup a single data file. If you want to backup multiple data files, you can say backup data file 1, 3. So you can combine multiple data files. You can also take the backup at the tablespace level. So you can say backup tablespace system, or if you want to combine multiple tablespaces, you can use the comma separated tablespace name. So this is the backup at the tablespace level or data file level. You can also take the incremental backups. Now backs up only blocks that have changed since the previous backup. So that's the incremental backup. So level 0 incremental is the same as full backup in content, but supports future incremental backup. So this is very important. So only the level 0 can be the baseline for your incremental backups. You cannot have the full backup. This is very important. And how we will take that? You will say backup incremental level 0 database. Now level 1 incremental, the level 0 incremental, and then you have level 1 incremental. Level 1 incremental are again divided into differential level 1 and cumulative level 1. Differential level 1 is a change since last level 0 or level 1. Cumulative is always the change since the last level 0 only. How do you take that differential? So you can see that is by default, the differential is the default. So you don't have the keyword called differential. You say backup incremental level 1 database, which will be a differential backup. If you want a cumulative backup, then you have to use the keyword called cumulative, which will take the difference from the last level 0 only. Now there is a note here, use BCT. BCT stands for block change tracking, and what it is we will see in future for faster backup. So when you want to take the incremental backups, make sure to use the block change tracking file. Now we will go a little bit in deep. So again, level 0 is a full baseline backup. Level 1 difference backs up all blocks changed since last level 1 or 0. Level 1 backs up blocks changed since last level 0 only. So what are the different types of commands you can, if you want to do at the database level? This is the full level 0 backup, the first backup. This is the level 1 differential backup. This is the level 1 cumulative backup. Now again, you can take the level 0 and level 1 at the tablespace level. So how you can do that? I've given you commands here, and you can do it at the data file level as well. So you don't have to take the level 0 backup at the full database level. You can do it at the particular tablespace or particular data file also. Now, the next type of backup is image copy backup. Image copy backup is a bit for bit copy of data files or archive logs. Can be restored directly without RMAN conversion. Now this is very important. It's a basically bit by bit copy. It is useful in incremental merge strategy. So you can say backup as copy database. You can say backup as copy database. What it will do is like it will physically copy all the data files belonging to the database. You can also take the archive log backup as a copy. So you can say backup as copy, archive log all. Image copies are slower to create but faster to restore. Now why they are slower? Because it will copy the data files, whether that is a used block, unused block, it will copy all of the files, all of the data files bit by bit. So if there is unused space, it will still be copied into the image copy backup. Image copy backups cannot be compressed. The backup set backups can be compressed. The image copy backups cannot be compressed. So that is also one thing. Now let me just show it to you. So here, if I go, let me actually show you a parameter called show all. That's where I keep my backups. So let's go to this location and let's actually do one thing. Yeah, let's go to that location. And let's say SQL plus as sysdb. Let's connect to the database and let's say select name from $data file. So let's see and let's go to this location in another session. So let's open one more session and let's go to that. And let's say ls. So let's actually do one thing. Let's say ls minus l star.dbf. And you can see this is my sysocs data file. This is my system data file. This is temp, this is undo, and this is users. Now what we will do is we will connect to the RMAN. And here these are all the original backup. These are the backup sets backup. This is full backup. This is the incremental backup. This is the level 1 backup. There is one level 1 backup here. So what we'll do, we will say RMAN target, and if I say backup as copy database, it's going to take an image copy backup. So you can say it's going to physically copy all of these data files. And I'm going to show it to you in a minute. So now let's exit. Let's do ls minus lrt. And now if you take a look, these are all the backups that it took today. So these are the backups that it took today. And if you take a look, the 9437, let me actually minimize. Let me actually do something. Let me minimize this a little bit so we can see this clearly. And if you see this, 94376592, that's a system data file, followed by your sysocs data file 992, followed by your users undo data file. Then we got the users data file. So it actually copied. You can see the size exactly matches. So this is the backup image, and this backup image, the size actually matches to the data file, which means it actually physically copied all the data files. These backups are slower to create. So let me do something, list copy of database. And now you can see, this is the image copy backup, and it actually has these physical files, which are nothing but the tablespace data files backup. So that's how you take the. So remember one thing: the image copy backup is bit by bit copy. It will physically copy the data file. So whatever is the data files, it will copy those data files. Now remember, it may not copy the temp file because RMAN never copy backups the temp file. So image copy backups cannot be compressed. Only the backup sets can be compressed. The next part is compressed backup. RMAN can compress backups sets to save space, so such as backup as a compressed backup set database. So in this case, it will create a compressed backup. RMAN can also take the encrypted backup. Encrypted backups can be password based. Transparent uses Oracle Wallet dual mode where it will use password as well as transparent Oracle Wallet. So you will say configure encryption for database on, and when you run the backup database, if the encryption has been set up and the wallet is open, you can use the backup database command, which will take the transparent backup, which will be encrypted backup. So you can take RMAN can take the compressed backup, it can take the encrypted backup. RMAN can also take the control file and SP file backup. So control file backup, if you want to take the backup of the current control file, you will just say backup current control file. And if you want to take the SP file backup, you can say backup SP file. This will take the backup of the control file. This will take the backup of the SP file. Now, if you every time you want to perform the backup, you can use an RMAN parameter called configure control file auto backup on. This particular parameter will make sure that every time you take the backup, whether it is a full backup, whether it is a tablespace level backup, data file level backup, whether it is a incremental backup, whether it is an archive log backup, automatically the control file will be backed up. And if the database is running on SP file, it will also include the SP file. Now, you can, while taking the backup of the database, you can specify backup database include current control file plus archive log. So this particular command will make sure that you are taking the backup of the database along with the current control file. So even if you have not set this particular parameter, it will take the backup of the current control file plus archive log. So it will take. So this is the one command which will take the backup of your database along with the control file along with the archive log. So this is a self-containing backup. Now let's understand the backups that we have, whatever the backups that we have covered. So these are the types of backups that we covered. So full backups, all blocks, full restore, key use, incremental level 0, it's like full but supports level 1, fast restore plans, incremental level 1 only change blocks, daily backups, image copy backup, bit for bit copy, fast restore, merge strategy, and we will see what is this merge strategy in future. Compressed backup, save space, long-term retention, encrypted backups, secure backups, offsite cloud storage, archive log backups, relogs backups. We have not covered this, which will come in future, which will support the point-in-time recovery, and control file SP file backup. This is the metadata backup recovery of your config of your database. So these are the some of the types of backups. What are those and what are the key use of those backups? Now that we have seen the different backup type, let's proceed with understanding what is image copy versus backup set. So image copy is nothing but exact copy of data file, which we have already seen. But backup set can be, it's a kind of compressed proprietary format. It's a RMAN format. It's not a physical copy. It's a RMAN format. You can use image copy. You can use the image copy. You can restore the database using OS stores, because of data files. You can use those data files. You can physically copy those data files. Backup set only usable via RMAN. In image copy, compression no. In backup set, compression is yes. Speed, image copy are faster to restore because it doesn't have to read the backup set. It's just a copy of the data file. You can just switch the database to copy. You can do that, or you can physically copy those data files. The backup set is faster to backup because it will not back up the unused blocks. However, image copy will copy the unused block. The way you can take the image copy, backup as copy database, you will say backup as backup set database. Block skipping, no, copies every blocks, yes, skips unused block. This is very important. Can be incremental. Image copies cannot be incremental. Backup set can be incremental. However, there is a note here. Image copies are full only, though can be updated. So when you take another image copy backup, you can actually you can update the previous image copy backup. You can use that image copy backup to sorry, when you take another level 1 backup, you can use that particular backup to update your base backup. So you can use that to update your base backup. So you have the latest backup. So you can use the faster recovery. So update with incremental, yes, you can use the recovery copy with block level incremental, and you cannot update the image copy, the backup set database. So backup set is a RMAN proprietary format. It can be compressed. It is faster for backup, but it is slower to restore. Image copy is exact file copy, uncompressed, slower to backup, faster to restore. Which to use? Use image copy when you want fast restore. Use backup set when you need efficient storage or compressed backups. So this is this slide about backup image copy versus backup set. Now, let's understand what is the backup set versus backup piece. Backup set is how RMAN organizes and tracks backups. Backup piece is actual file stored on a disk tape containing the backup data. So backup set is just a logical. It's not actually physical. What is there inside that backup set is what is physical. So backup piece is within the backup set. So let's say you take a full database backup, and I have not done this, but let's say you have a full database backup, and you set 4 channels and you set the parallelism to 4. And when you run the full database backup, it will create 4 different files. So let me put it in a notepad. So let's say you set the parallelism to 4 and you set the channels to 4, and then you take the backup, and this particular backup, when you take this particular backup, it will create 4 different files, and these are called backup pieces. However, all of this is part of the backup set. So backup set is logical and backup piece is physical. So backup piece is actual. So backup set you can think as a folder, and backup piece is a file within that. So backup set is a logical, backup piece is physical. Let's move on. So backup set is a logical grouping of backup piece created by RMAN. It is the output unit of RMAN backup command. A backup set can contain data file backups, archive redo log backups, control file backups, SP file backups. A backup set can contain one or more backup pieces depending on how you configure RMAN. Example, max piece size, files per set, parallelism, etc. So based on how you have configured your RMAN, a particular backup set can have one or more backup pieces. Now, a backup piece is a physical file written to disk or tape that contains backup data. It is an actual file stored in your backup destination. Each backup set is made of one or more backup pieces. Backup pieces are usually in binary format, not readable without RMAN. So backup piece you cannot read because they are RMAN proprietary format. So you can only read those files in RMAN. You cannot read them using OS utilities. Now, let's understand the no archive log mode. In no archive log mode, redo logs are not archived. Once a log file is full and reused, its contents are lost. No archive log supports full cold backups. You must shut down the database to take the backup. Remember, when you say you need to shut down the database, you need to put the database in actually mount mode. You have limited recovery options. You can only restore from the last cold backup. Changes since then are lost, which means that if you have taken a backup last week and you don't have any backup after that, you cannot, whatever happened during the current week, that's all gone. You don't have a choice to restore them. So what are the pros? Less disk space used. Why? Because you don't have to worry about the archive logs. Simpler to manage in test and dev environments. Cons, no point in time recovery because you can only restore to the last cold backup. No online backups. You have to put the database, you have to stop the database or mount database. Higher risk of data loss. Let's understand about archive log mode. In archive log mode, redo logs are archived. After a redo log is filled and cycled out, Oracle saves a copy to a designation. Supports point-in-time recovery. You can recover the database to any point between backups using archive logs. This is very important. Supports point-in-time recovery. Required for hot or online backups. You can backup the database while it's running. Now, archive log mode is the only mode which allows you to take the backup while the database is completely up and running. It is best suited for the production environments. What are the pros? Enables full recovery in case of media failure, allows online backups with tools like RMAN. Data loss can be minimized or avoided. What are the cons? Requires more disk space for archive logs, needs log management, deleting or moving old logs because archive logs will fill up your disk. You need to either move them or delete them after taking the archive log backup. Now, what is this archive redo log? The archive redo log consists of redo log files that have been archived before being reused. Now, remember one thing: once the redo log is used, before it has to be reused by another transaction, it has to be archived, and that's what is archive redo log. So, archive redo log is a copy of your redo log file, and that copy of redo log file is before another transaction overwrites it. It's like a safe copy. Oracle automatically archive log file when the database is in archive log. You don't have to worry. You can manually do the archive log. You can alter system archive log current. You can use that commands. However, Oracle automatically archives the log file. This prevents Oracle from overwriting the log files before they have been safely archived. So this is very important. Oracle will make sure that the redo log files are never overwritten if the database is in the archive log mode. What happens if the location where you have stored the archive log is full and is not able to archive it to that location? What will happen? Database will get hung. However, database will never allow you to overwrite the redo log file. This is very important. In archive log mode, if the space, it won't happen like, Oracle will try to archive the log. It cannot archive the log. Let's overwrite the current redo log file. It won't happen. Oracle will not allow you to overwrite the redo log files unless until they are archived. This is very important. By default, database runs in no archive log mode, which means we can't perform online or hot backup. You must shut down the database to perform clean cold backup, and recovery can be done to previous backup state. Archive log file solves this problem by allowing you to perform point-in-time recovery and performing backup when database is open. Archive log files are stored in a default location called FRA, which stands for Flash Recovery Area or Fast Recovery Area. Old name was Flash Recovery Area, new name is Fast Recovery Area. We can also define our own backup location by setting log arg-1. There are multiple log arg parameters. Log arg-1 is the first parameter that we will set. There are multiple other parameters also. Remember, without archive logs, only incomplete recovery is possible, which means point-in-time recovery is not possible without archive logs. Now, how to find the database log mode? You can use archive log list command, or you can say select log mode from v$database. Archive log list or select log mode will give you the current archive log mode used by the database. How to convert the database to archive log? Create a directory where you will store your archive locations. Set the environmental variable. Connect to the SQL Plus SSDBA. Set the archive log arg-1 parameter. Set the log archive format. This particular format, if you don't set it by default, there is already a format defined. It will use the default format. However, it's always better to define your own format. Shut down the database. Start up the database in mount mode. Alter database archive log. Verify that it is in the archive log using archive log list. Alter database open. Now, remember one thing, archive log can only be configured in the mount mode. Remember, if you want to convert the database to archive log, you have to start the database in the mount mode. So you need a downtime for this activity. Now, what are the archive log backups? I said this before that we have not covered the archive log backups, which I will cover in the future. So to backup all archive logs, you will say backup archive log all. You can use the delete input option to clear archive logs after backup. So once the archive logs are backup, you don't want those backups to be there. You can say delete those input, which means that the archive log backups which have been backed up will be deleted. To backup all archive logs that have not been backed up at least 2 times. So you can say backup archive log all not backed up to 2 times. So this command will make sure that there are at least 2 backups of your archive log. If there are 2 backups, it will delete the archive log. To backup all archive log that were created in last 2 days, so you will say backup archive log from time sysdate -2. So it will, this particular command will only take the backup of those archive logs which are created in the last. There are multiple other variations of this command. These are the some of the commands. Now, this command will take only the backup of the archive log. Now, you can also include the archive logs along with the full database backup. So, backup database plus archive log. This command will take the backup of the database along with the archive log. Now, let's understand what is FRA or Fast Recovery Area. In Oracle, FRA stands for Fast Recovery Area. It's a centralized storage location on disk where Oracle automatically manages files related to backup and recovery. FRA is a disk-based storage location configured for archived logs, RMAN backups, flashback logs, control file and log copies, data file copies, other recovery related tasks. Now, these control file and redo log copies. So if what you can do, if you are using the multiplexing, then you can use one of the FRA as another location for your control file and redo log file. Or you can say you can unuse that. It's your choice what you want to configure in FRA. Now, Oracle manages this space automatically, deleting obsolete or redundant files when needed based on backup retention policies and space availability. So, the FRA is managed by Oracle internally. Why use FRA? Using FRA simplifies backup and recovery operations, especially with RMAN, and ensures that critical recovery files are in well-managed locations because it stores all of this together: the redo logs, RMAN backups, flashback logs, control file and redo log copies, data file copies. So this is a centralized location. So it contains all of the files which are required for you to recover or restore your database. That's why you should use FRA. How do you set the flash recovery area or fast recovery area? You can, again, I'm using here flash recovery area. Flash recovery area is the older name. Fast recovery area is a newer name. You can use any of the term. However, better to use the fast recovery area. That's a newer name. Now, how to set the fast recovery area? You can use alter system set db recovery file dash size is equal to 10G. So you first have to set the size and you need to set the recovery file destination. You don't have to bounce the database. These parameters you can set online. How do you check how much FRA used? You can use $recovery file dash this one. So name, space limit, space used, reclaimable number of files. You can use this, all of this from the $recovery file dash, which will give you the current used space in the FRA. How do you handle the situation where FRA is full? So first you can check using the same $recovery file dash. You can see the usage. You can use the delete obsolete command. So free the space by deleting the obsolete backups or deleting the old archive log. So you can say delete archive log all completed before sysdate -2, which will delete the older archive log. Now, if you cannot free the space using delete obsolete or delete archive log, then consider increasing the FRA or moving the archive logs out. Now let's understand the concept of RMAN recovery catalog. Recovery catalog is a schema in separate Oracle database that stores metadata about RMAN backups, archive logs, and database schema. It offers backup history across database incarnations, centralized backup information for multiple databases, support for reporting and scripting. So RMAN recovery catalog is basically a schema. Now remember one thing, you can create this schema in the same database which you are trying to backup, but that serves no point. You should not do that. You should always designate a separate database as your recovery catalog. A recovery catalog is useful for long-term and cross-database RMAN operations. So it is useful. I've written this useful twice, but ignore that. So recovery catalog is useful for long-term and cross-database RMAN operations. Make sure each database has unique DB ID before registering into RMAN recovery catalog. make sure each database has unique DBID. This is very important. Once you understand the concept of RMAN recovery catalog, you will understand why the DBID comes into the picture. You should always make sure that each DBID which you are registering in the recovery catalog is unique. Also, make sure recovery catalog is stored in different and dedicated database. This is also important. Make sure recovery catalog is stored in different and dedicated database. Now, how do you create recovery catalog? There are exactly 3 steps. You create a recovery catalog database. Basically, you say create a dedicated table space. Then you will create a recovery catalog owner, create using create user, and then you will create the recovery catalog using RMAN create catalog. So create a dedicated table space, then create a user. This user becomes the recovery catalog owner. Set the default table space for this user. Whatever table space that you created, set that particular table space as a default. Provide unlimited quota on this table space to that user. Then grant the recovery catalog owner to the user. Then connect to the RMAN and specify create catalog command. So these are the steps of how you will create the RMAN recovery catalog. Now, difference between an RMAN recovery catalog and control file repository. So the control file repository is the default backup metadata repository used by RMAN. Key characteristics are located in current control file of the target database, stores backup metadata like backup sets and pieces, archive logs, data file copy information, restore recovery history. So it basically, if you don't use the RMAN catalog, by default, the RMAN will store the information about your backups in the control file. It is automatically maintained by RMAN. You don't have to do anything. No separate database required because control file is the part of your database. Limited history. It is controlled by an initialized parameter called control file record keep time. So whatever is here, this particular parameter will define how many days this particular history will be kept in your control file. Limitations. Vulnerable to loss if control file is lost and not backed up. So you will lose all of your backup information. If you don't have the backup of your control file, you lost all of this information. So you don't even know what backups you have because you don't have the control file, because that's where your backup information is stored. Limited history. Records gets overwritten when the limit is reached. So when this particular limit is reached, when it reaches to a limit, it based on this particular parameter, it will delete older data. Cannot track backups across multiple databases or long-term retention. So if you want to know backup of another database, control file doesn't help you because it only keeps the backup of the current database. That's where the RMAN recovery catalog comes into the picture. It is a separate Oracle database schema and optionally a separate database together. Remember, you can create this schema in the same database. However, that serves no point and you should not do it. So Oracle, it's a schema, but you should save this schema in a separate database, and it is used to store RMAN metadata persistently and centrally. Key characteristics. It is created with RMAN create catalog and used with register database. It stores all metadata from the control file plus metadata for. So whatever is there in the control file, it will store in the recovery catalog, plus it will store metadata for multiple databases. It will store historical data beyond what control file can retain. So it will store more than what control file has. It can store the scripts, it can store the retention policies, and it can give you the detailed backup reports. Advantages. It is a centralized backup metadata for many databases. It retains long-term history. It survives loss of control file. Even if you have lost the control file, you can use the recovery catalog to recover. Based on your information, based on the information in the catalog, you can know what backups you have, and you can use those backups to recover from your database lost. Now, what are the requirements? Requires setup and maintenance because it needs its own database schema, needs to be resynchronized regularly with the control file. So these are some of the requirements of your recovery catalog. Now let's understand some of the RMAN list command. So list backup will give you the backup of all the backups. List backup of database, only the database backups. List archive log all. This is not the backup of archive log. These are the list of archive logs. List backup of archive log all will give you the archive log backups. So remember, the list archive log all is the list of archive logs, and list backup of archive log is the backup of archive log. If you want to see the backup set, you can use list backup set. If you want to see the backup sets of the database, only the backup set of the database, you can say list backup of the database. If you want to see the image copy backup, you can say list copy. And if you want to see the image copy database of the backup of the database, you can say list copy of database. These are some of the RMAN list commands. Now let's understand about RMAN retention policy. The RMAN retention policy is, there are two different policies. One is the recovery window and one is the redundancy. Recovery window indicates that RMAN will try to keep the backups based on the recovery window. So let's say you have set the recovery window to 7 days and today is August 28, then it will keep the backups needed to restore the database to any point since August 21. So you can recover your database from August 21 to 28. It will keep all these backups. Any backups taken before August 21, like such as August 20, August 19, RMAN will consider them as absolute backups. They are no longer required for your recovery or retention policy. So any backups older than that needed for recovery are marked as obsolete and can be deleted. So this is a retention policy based on the window. You can also have a retention policy based on the redundancy. So let's say you say, I want to have a redundancy of 2. So this means that our Oracle will keep 2 backups of each data file and control file and SP file. Once you have more than 2, the older ones can be considered. So let's say after 3 days, you will have 3 full backups. So let's say you are taking full backup every day. On the 3rd day, you will have the 3 full backups. The first backup is no longer required because redundancy is 2. So the day 1, the oldest backup is now absolute. How do you check the current retention policy? You can say show retention policy, which will show you the current retention policy of your database. Let's understand what the absolute backups in RMAN. RMAN does not delete backups automatically. It only marks them obsolete according to the policy. Obsolete backups are those which are no longer needed to satisfy the retention policy. Now, let's understand obsolete backups are those. So if you have set up the retention policy, the obsolete means that those backups which are no longer needed to satisfy the retention policy. RMAN determines them using report obsolete. To actually delete them, you can run delete obsolete or delete no prompt obsolete. So the report obsolete, basically will list the obsolete backup. Then physically you can delete them, or you can mark them from the you can delete them using the delete obsolete or delete no prompt obsolete. Now the RMAN cross-check command. Cross-check checks whether backups and archive logs in the RMAN repository still exist on disk. So obsolete backups is based on the retention policy. However, cross-check will check whether the backups which are there in the RMAN catalog or RMAN control file are those backups there on the physical disk. So cross-check backup will check whether those backups are present on the disk. Cross-check archive log all you can use to check whether there is any archive logs which are deleted. Once those archive logs, if those archive logs or backups are not there on the disk, they are marked as expired, and then you can use delete expired backup. So this is very confusing. Cross-check will check the physical thing. Obsolete will check the retention policy. If the backups are not there physically on the disk, they will be marked as expired, and then you can delete them using delete expired backup. So let's understand the difference between cross-check and report obsolete. Cross-check verifies the existence or status of backups. Report obsolete list backups no longer needed based on the retention policy. Difference between delete obsolete and delete expired. Delete obsolete will delete backups not needed for retention policy. Delete expired deletes records of backups marked as expired which are missing on disk or tape. So now that I believe you are clear with how the absolute backup works and expired backup works. Let's understand the block change tracking. Remember, I mentioned that when you take the incremental backups, you should enable the block change tracking. So what's the block change tracking in RMAN? So block change tracking in RMAN is an Oracle feature that significantly improves the performance of incremental backups by recording changes to data blocks in a special file. So basically it's a separate file, and that particular separate file records the changes to data blocks. This allows RMAN to avoid scanning every data file instead only backup the blocks that have changed since the last backup, which means your backups will be faster. So purpose of block change tracking, by default, RMAN must scan all data file blocks to determine which ones have changed since the last backup. Even if a small number have changed, this is time consuming. With block change tracking, Oracle tracks changed blocks using a change tracking file. During incremental backups, RMAN reads only the changed blocks, which speeds up the process. So block change tracking is always a definite plus during your incremental backups. How to enable block change tracking? You can say alter database enable block change tracking using file, and you can give the name of the file. If the block change tracking, if you have set the db-cred file dash, then you don't have to give the full name of the blockchain tracking. You can say alter database enable blockchain tracking, and then you can say select file name status bytes from VDollar blockchain tracking, which will tell you whether the blockchain tracking is enabled or not for the database. Now, additional notes about blockchain tracking. Blockchain tracking is a separate file from our data files and control files. It only affects incremental backups. Full backups don't benefit from blockchain tracking. That is the impact of blockchain tracking, because every time you insert, update, delete, basically any DML operations, you need to record what block changed in a separate file. So that is a small overhead of less than 1 or 2%. The setting is persistence across database restart, which means once you create a blockchain tracking, it will stay there. That particular file will be there. For some reason, you deleted the blockchain tracking, then when RMAN tries to take the backup, it has to do the full scans because it no longer has the blockchain tracking. So it will fall back to full scan. Now, how does it help? So let's say you are doing daily level 1 incremental and weekly level 0 backup. With blockchain tracking enabled, the daily incremental backups will be much faster because RMAN can directly access those change blocks using the blockchain tracking file. So this is the blockchain tracking. Now let's understand how do you validate RMAN backups. To verify the integrity and usability of backups, you can use validate backup set number. So you can use this is the backup set number. You can say, let's try to see if we have any backup. So if I say list backup set, let's do this. And this is the backup set number. And if I say validate backup set 9, and then basically it is going to validate that particular backup. And if there is any error, it's going to record it in a separate table, which we will basically it will store that information in VDollar database block collection. So this you can use validate backup set. If you want to check the entire database, you can use validate database. If you want to check the integrity of your entire Oracle database, both physically and logically, without actually taking or creating a backup, you can say backup validate check logical database. So you can, without creating a backup, this particular command will validate or check your logic database. Now this particular RMAN also supports block media recovery. So if there are any corrupted blocks when you run this validated database or validated backup set, if there are any corrupted blocks, then those corrupted blocks will be stored in VDollar database block collection. Remember one thing, when you try to take the full backup also or any types of backup, if RMAN finds out if any blocks are corrupted, it will store that information in VDollar database block collection. you can say recover data file for block 20. So if a particular block is corrupted, you can just recover that particular block. Or if you want to recover all the blocks which are listed in vDollar database block corruption, you can say block recover corruption list. What this command will do, it will read the all the blocks which are present here, all the corrupted blocks which are present, and it will try to recover those blocks, provided you have a good backup. Now, how do you detect block corruption? So there are multiple ways of detecting block corruption. RMAN validate commands, which we have just seen. Oracle DB verify utility against the offline data files. DBMS repair packages used against a table, index, or partition. Init or parameter DB block checking, which checks data and index block each time they are created or modified. Analyze table validate structure. So these are the multiple options of detecting block corruption. Let's see all of these in details. So analyze table validate structure command, this particular command checks the block integrity. So you can check the block integrity if the data blocks belonging to table are not corrupted. It will also check if there is a row chaining or migration. Basically, this is the concept of performance, and I don't want to get into this, but if some rows are not on the same pages, they have been migrated to another pages, then that becomes the migration or chaining, which can impact the performance. It can also check the index consistency. If the table has indexes, it also validates the consistency between the table data and its corresponding index entries. What's the Oracle DB Verify? So DB Verify is an external command line utility that performs physical data structure integrity block. DB Verify can be used on offline or online databases as well as on backup files. You can use DB Verify primarily when you need to ensure that the backup database is valid before it is restored. So you can give the name of the backup file, feedback, and you can use the DBV command, which will basically check the integrity of this particular. Again, you can use this is a very big utility, and you can use this particular utility to do various kinds of checks. The init or parameter DB block checking can check the data and index blocks each time they are created or modified. So this is the another thing. We have already seen the RMAN validate database will validate the entire database. You can validate a particular data file, validate database file 5. You can use this particular command to validate a particular data file. Another way is DBMS repair. So DBMS repair package contains data corruption repair procedures that enable you to detect and repair current blocks in tables and indexes. You can address corruptions where possible and continue to use objects while you attempt to rebuild or repel them. Oracle checks a block by going through the data in the block, making sure it is logically self-consistent. Block checking can often prevent memory and data corruption. So this is very important. Block checking can prevent memory and data corruption. Block checking typically causes 1 to 10% overload in most applications, depending on. So if you try to do the block checking while the database is up, you should avoid trying to do the block checking while the database is up and running or used heavily, because it will create an overhead. Now let's understand how do you perform an incomplete recovery using RMAN. So if you want to recover until a specific time, you will say set until time to date. Then once you set the until time, you can use restore database, recover database, and you can use the database in reset logs mode. Set until time has other options: set until SCN, set until sequence. So you can use the set until SCN or set until sequence. Now, one of the key consideration here is what is this reset logs. So reset logs is used after incomplete recovery or cloning. It resets the redo log sequence and starts a new incarnation. No reset logs is used after complete recovery. Redo log sequence continues unchanged. So when you perform the complete recovery, you will use the no reset logs. And if you ever perform the incomplete recovery or you clone the database, you will use the reset logs option. Now, how do you duplicate a database using RMAN? To clone the target without requiring backups by connecting to the live source, there is something called active duplication. So you can use duplicate target database to new DB name from active database. So there are multiple options. So let's say you will have to connect to the target. So the target is actually your source and auxiliary is the one which you are going to duplicate. So this is the main database. This is the duplicate database. So if you want to duplicate the database, you will say duplicate with the same name. You can say duplicate database to or R19D from active database, no file name check. If you want to duplicate a database with a different name, you can say duplicate target database to the new name from active database. You can use the SP file. You can set the DB unique name to new name and no file name check. What is this no file name check? We will see in a minute. So no file name check in RMAN duplicate. No file name check is used in duplicate command to allow the duplication of database even when the data file names in the duplicate database are same as those in the source database. So let's say you are trying to duplicate a database from source to target and the file names are exactly same, then you should use the no file name check. But if you don't specify the no file name check, the default RMAN checks the data file paths in auxiliary instance do not match the ones in the target database to prevent accidental overwriting. So it will make sure that to avoid overwriting of the data files, it will by default check the paths. If you are duplicating a database on the same host or using the same file structure, this check will fail unless you specify the no file name check. When to use no file name check? You are duplicating to the same host or an environment where file paths are identical between source and auxiliary. When the file paths are same, then you should use the no file name check. And you understand and accept the risk that this might overwrite existing files in auxiliary environment, because when you are saying no file name check, it will not check the paths or files and it might accidentally overwrite the exiting files. When not to use it? If your duplicate database is using different file locations than the source, not required. If you are on a different server and you told RMAN to generate new paths using DB file name convert or log file name convert, you don't have to use the no file name check. Remember, using no file name check incorrectly can lead to data loss if RMAN overwrites existing data files in source or critical environment. So you should be very careful when using the no file name check when you are duplicating the database. Let's understand the difference between active database duplication and backup based duplication. As if you are aware, there are two methods of the duplicating the database in RMAN. One is called active duplication, one is backup based duplication. In active database, it copies the live database blocks over the network. It uses the existing backups. It is slower because it is depending on the network, because you need to connect to the source database, and over the network it will copy the data files. Backup based duplication is faster because backups are local. In case of active duplication, the target database, whichever database you are trying to clone, that must be open and accessible. You don't need to connect to the target database, so the target database can be offline. The command would be duplicate target database to duplicate database from active database, and here the command would be duplicate target database to duplicate database backup location. You have to give the backup location where you have stored the backup. Active duplication is often used when no backups are available or quick clone is needed for testing, because you don't have to take the backup, you don't have to transfer the backups, etc., etc. So active duplication is often used when no backups are available. So these are the two types of duplicate cloning that RMAN provides: the active duplication and backup based duplication. Can RMAN be used with standby database? Yes, RMAN supports backup of physical standby database using standby backups for restore and recovery of primary, or duplicating a standby from primary, or vice versa. So you can take the backup at the standby. RMAN fully supports backing up the standby database. Now, how do you monitor the RMAN backups? There are multiple ways of doing this. You can use VDLR RMAN backup job details. So you can see if the backup is running or it's completed, then you can see the status, start time, end time. So if you run this particular query, you will get the information about your RMAN backups. If you want to see those backups which failed, you can use VDLR RMAN status, where status is not completed, which will give you the backups which have failed. Now there are multiple options as I mentioned. $RMAN backup job details displays details about backup jobs. RMAN status displays finished and ongoing RMAN jobs. $session logops provide information about long-running operations, including RMAN backups. Let's see this in detail. So $RMAN backup job details, you can see the input type, status, when the backup started, when the backup ended, how much time the backup took, etc., etc. So you can get all of this information from $RMAN backup job details. You can also use the $session long ops. $session long ops is nothing but a query which a view which provides information about long running operations, including RMAN backups. You can query it to see the percentage completed, estimated completion time, other details for active RMAN. So how will you find it out? So you can use the so far, total work, how much is the completed, how much is the total work, what time started, how much is the remaining time, how much is elapsed seconds from the session long ops, where operation name is equal to like RMAN and total work is equal to greater than 0, where so far is not equal to total work. So you can use the session log ops to get the information about your RMAN backup. Let's understand the RMAN configuration. So the RMAN allows you to set some of the parameters at the persistent level. These particular parameters are stored in the control file. So when you set these particular parameters, what it basically defines the way the RMAN is going to take your backup. So by default, the control file auto backup may be turned off. If you want to turn this particular parameter on, you will say configure control file auto backup on. Then you will see new RMAN configuration parameters are successfully stored. And then if you see the show all, it will show you configure control file auto backup is on. So what this particular parameter, it basically there are multiple parameters such as retention policy, backup optimization, the max set size, encryption, compression algorithm, the RMAN output, etc., etc. And these particular parameters defines some of the policies such as, what is the retention policy, etc., etc. Or some of these particular parameters defines how the RMAN is going to take the backup. So if you set the compression algorithm to low, medium, or high, it will compress the backup. If you have set the encryption for database to on, it will try to create an encrypted backup. If you have set up the parallelism to multiple, then it will create multiple backup pieces. So basically, this particular parameter defines how the RMAN takes the backup or how the RMAN stores the backup. So this is the RMAN configuration, and you can change this particular parameter based on your environmental needs. You can use the configure command and you can use show all command to see these parameters. Now, what is a DBID? So DBID is internal unique identifier for a database. RMAN distinguishes the databases by DBID. This is very important. RMAN distinguishes the databases by DBID. RMAN duplicate database command changes the DBID automatically. So when you use the traditional backup and restore, the DBID will remain the same. However, if you want to have a different DBID, then you have to you can use the new ID utility, which will generate a different DBID. Or if you don't want to do that, you can use the duplicate commands, the active duplication or backup based duplication. Those commands will automatically give a new DBID. And remember, it's an internal unique identifier for a database. Let's say you created a database in your environment and then you created another database. Probably your DBID will be different for these two databases. Now, let's understand a question: how to improve an RMAN performance. So RMAN performance can be improved by various ways. Enable blockchain tracking. If you enable the blockchain tracking, it will speed up the incremental backups. Use parallel channels, faster backup and restore. Compressed backups saves space. However, the trade-off is CPU because the backup has to be compressed. Enable backup optimization, which will skip unnecessary files. Use backup sets, which will allow you to compress the backup. Use image copy for faster recovery. Monitor the RMAN jobs. So if you using some of the inbuilt queries, you can find out if the RMAN is running slow, and try to write to fast storage for faster backup and restore. So you can use the fast storage. So these are some of the options how you can improve your RMAN performance. We have already seen the block change tracking. However, for the completeness, we will see that. So block change tracking is an Oracle feature that improves the performance of incremental backups by recording changes to data blocks in a special file. This allows RMAN to avoid scanning every data file, instead only backs up blocks that have changed since the last backup. So by default, RMAN must scan all data file blocks to determine which ones have changed since the last backup, even if only small number have changed. This is time consuming. With block change tracking, Oracle tracks change blocks using change tracking file. During incremental backups, RMAN reads only change blocks, which speeds up the process. So block change tracking is a feature which improves the performance in incremental backups. Parallelize RMAN operations. You can allocate multiple channels, such as you can allocate here. We give an example. We have allocated 2 different channels. So you can allocate multiple channels and you backup database. So by default, Oracle will try to take the backup into 2 different channels. So you can configure multiple channels or configure it globally. So you can configure device type disk parallelism to 4 and configure channel device type disk format to %u, which will automatically create a new channel configuration. So you can use these channels while performing the backup as well as performing the restore. Now, when you choose these channels, try to match the channel count to number of CPU cores and disk throughput capacity. So if you create multiple channels but you are not able to write to the disk at that channel, there is no point. Or if you have only one CPU and you have allocated 4 channels, which means that same CPU is used to write to all the 4 channels. That is also not a good idea. So try to balance between the CPU cores and disk throughput. So again, the compression, we have seen that RMAN can take the compressed backup, and this particular backup reduces the storage but adds CPU overhead. Remember that every time the backup has to be taken, it will use the CPU because it has to compress that particular backup. So how do you you can configure the compression algorithm to medium, and then you can say backup as compressed backup set database. This particular backup will be compressed backup, and this particular backup will be using the medium algorithm. Or you can actually configure it globally. So you can say configure compression type algorithm and then configure device type disk backup data to type to compress backup set. And when you do this, when you run this particular command, and when you just say backup database, you don't have to say backup as compressed. When you say backup database, it will be compressed backup because you have set the RMAN parameter. Now remember, when to use the compression when the disk IO is bottleneck, because when you use the compression, the backup output will be smaller. However, remember, CPU will be used. So only if the CPU is underutilized, try to enable the compression. Configure backup optimization. Avoid unnecessary backups. Configure backup optimization on. This particular parameter will skip backing up files that haven't changed since the last backup. So if RMAN has already taken the backup and you have set this particular parameter, then RMAN will not take another backup because the RMAN will know that this particular backup has been taken and no longer need to taken. So you can use this particular parameter to decide or skip those files, backup files, which are no longer required. Use backup sets. This is slightly confusing answer. So here I'm saying use backup set. Here I'm saying use image copy. Now you cannot use both. Either you can use backup set or you can use image copy. So why to use backup set? Backup sets are more compact and faster to write. And basically backup sets can be compressed. Remember that. But use image copies only when required for quick restore. So if you want to restore your database quickly, then use the image copy. So what you can do, you can use the incremental merge for the image copy. So you can use with incremental merge backup. So backup for recovery of copy database. What this particular command will do, it will actually merge. So it will be always, your copy backup will be always to the latest point. So let's say you want to recover your database, and you when you say backup for recovery of copy, you actually update your image copies and restore becomes very faster. So use incremental merge or faster recovery, this particular image copy backup. So when to use image copy backups? When you want the faster restore. But remember, image copy backups is slower to take because it's a full backup, it's full data file backups. Now you can, to improve your RMAN performance, you can use multiple queries such as $RMAN backup job details, or you can use the $session long ops. We have already seen these queries. So this particular queries will give you how much time the RMAN backup is taking and how you can improve the performance. You can use the enterprise manager to analyze the performance. Now, one of the most important, when you try to take the backup, remember to try to fast storage. So backup destination, disk or tape must be fast and separate from database storage. This is very important. Don't try to take the backup on the same location where your database files are stored, and prefer dedicated backup disk or direct to tape for large environments. Now, how many RMAN channels to allocate? This is one of the questions that you might come across. So number of RMAN channels to allocate in RMAN depends on several factors. Number of CPUs, don't exceed CPU capacity. So one channel per CPU. So you have, based on how many cores you have, your server has, based on that you define how many channels you are going to use. Disk IO throughput, if disk is slow, too many channels can overwhelm the system. So remember, if your disk is slow, don't try to create multiple channels. Tape or disk backup. Tape devices often benefit from more channels. For disk, depends on disk speed and IO. Parallelism support. Configure appropriate parallelism to avoid congestion. Size of database. Larger database often benefit from multiple channels to speed up the process. Backup device limit. Tape drives and SAN NAS system may have channel limitation. So if you are trying to take a disk backup, 2 to 4 channels for small to medium databases, 4 to 8 channels for large database if storage can handle parallel writes. Tape backups, match number of channels to number of tape drives available. General rule, allocate as many ad channel as your hardware and IO subsystem can handle without congestion. You can use the $RMAN status or session long ops to monitor your channel usage. Now, what processes are used by RMAN? Oracle RMAN uses several processes to perform its task of backup, restore, and recovery. And these processes can be background processes, server processes, or channel-specific processes, or depending on operation being performed. So what are the server processes? Primary processes that executes. So server process is a primary process that executes RMAN commands. It interacts with database via SQL and PL SQL to manage backup and recovery. Archive log. If database is in archive log mode, RMAN interacts with archived logs generated by RCAN. Database writer. This is not directly invoked by RMAN but may be involved during checkpointing and writing dirty buffers when backup is taken. Checkpoint process helps ensure consistency during backup by coordinating checkpoints. Log writer writes relog entries. RMAN relies on relogs for point-in-time recovery and block media recovery. Then we have RMAN specific processes such as channels. Channels are server sessions started by RMAN to perform backup, restore, and recovery. Each channel is associated with a dedicated server process on the database and corresponding process on the media manager if tape storage is used. Media management layer SBT interface. When using tape or third-party storage, RMAN communicates via media manager through Oracle's SBT API. In this case, additional processes may run depending on media manager used, such as NetBackup or TSM. Recovery process used when distributed transactions are involved, not directly controlled by RMAN, but may come up into play during recovery. Operating system process. Depending on how RMAN is invoked, example from command line or scheduler, RMAN runs as an OS level client process that connects to target database and optionally to recovery catalog. So these are some of the processes. So let's understand the processes. So server process, this is the process which executes the RMAN commands. Channels, RMAN performs backup restore one per allocated channel. RCAN generated archive logs used in recovery. Log writer writes log used in backup consistency. Checkpoint coordinates checkpoints during backup. Media manager for the third party interface with RMAN for tape disk backup, IO slaves, optional for improved IO performance, recovery catalog, and optional for storing metadata about backup. So these are the some of the RMAN processes. Now let's understand what's the snapshot control file in Oracle. Snapshot control file is read consistent temporary copy of control file that RMAN uses during backup and recovery operation. RMAN uses this snapshot to avoid contention with live control file while it's performing tasks that read metadata extensively, such as backups of data files or archived logs. Why it is needed? So control file is constantly updated by log writer, arc check CKPT, etc. If RMAN try to access it directly during operations like backup or restore, it could cause data consistency issues, performance bottlenecks, control file corruption in extreme cases. To prevent this, RMAN takes a snapshot, which is a static copy of the control file, and uses that for its internal queries and metadata query processing. So snapshot control file, let's understand a little bit more. So RMAN uses snapshot control file to ensure a read consistent view of control file during various operations such as resynchronizing the recovery catalog, backing up the control file. So when RMAN interacts with a recovery catalog, it needs a stable version of control file to update the catalog's metadata. So that's why it will create a snapshot control file. If you are trying to take the backup of control file, it will first create a snapshot control file and it will take the backup of that control file. It is created for the duration of specific RMAN operation and is typically overwritten by subsequent. So it will, if you have configured a snapshot control file, it will when RMAN is invoked, it will create it, and next RMAN operation will overwrite that particular file. Default location. Oracle typically creates snapshot control file in same location as fast recovery area or db create file rest. You can use show snapshot control file name to look at where the control file is stored, or you can use configure snapshot control file name to different location. You can use the RMAN parameter to configure the snapshot control file name to a different location. Now let's understand what is system change number. So system change number, or commonly referred as SCN, is unique number assigned to transaction which modifies data in the database. Checkpoint process updates the control file and data file headers with checkpoint information and signals DB writer to write blocks to disk. Checkpoint information includes the checkpoint position, SCN, and location in read log to begin recovery. So checkpoint process is the one which actually writes the SCN to control file and data file headers. Now, there is another process called log writer, and this particular log writer writes the SCN to the log files. Basically, from the redo log buffer, it writes to the log file. So when a user issues a commit, the transaction is assigned a system change number, and that log writer puts a commit record in the redo log buffer and writes it to disk redo log immediately along with the commit SCN and transactions redo entries. So CKPT is responsible. Checkpoint process is possible to update the control file and data file headers. Log writer updates the redo log file. So remember, the log writer updates redo log file, and that is nothing but your commit SCN, and this is your checkpoint SCN. Now, let's understand a little bit more because this is a very confusing topic. So system change number is an ever increasing value that uniquely identifies a committed version of database at a point in time. Every time a user commits a transaction, Oracle records a new SCN in redo logs. Oracle uses SCN in control files, data file headers, and redo logs. Every redo log file has both a log sequence number and a low and high SCN. Low SCN records the lowest SCN recorded in the log file, while the high SCN records the highest SCN in the log file. SCNs are encrypted as changes happen: insert, update, delete, etc. Each change gets a new SCN. Now, even if there is no database activity happening, under very low or no activity, still the checkpoint will be updating. Oracle forces an SCN increment every 3 seconds to prevent SCN from stalling. So even if there is no update activity happening, you will still find SCN is incrementing. So basically the rule is every 3 seconds it will automatically increase. How can you see the current SCN number of the database? You can see select current SCN from the VDLR database, and from the log you can say select sequence number first chain number, next chain number from the VDollar. So you can use either the current SCN from the database or from the VDollar log. Now, there is also a concept of log sequence number. Now, SCN is system change number. This is a log sequence number. Log sequence number is a monotonically increasing number that uniquely identifies each redo log file, also called redo log group, as it is filled and archived. So, log sequence number is associated with the redo log group. It is a sequence in which redo log files have been used and archived log files are to be used in case of recovery. So it is basically a sequence. When every new redo log file or redo log group will get a new SCN, a redo log group will get a new log sequence number, and this particular log sequence number will tell when you initiate a recovery. It will tell in which orders the logs has to be used or applied. Basically, the log sequence will tell the Oracle database in which order the logs or archive logs to be used. Log sequence number is incremented each time a log switch occurs. When Oracle switches from one redo log group to another, basically a new log sequence number is generated. Log sequence number is crucial for recovery. Oracle uses log sequence number to recover from crash by replaying redo logs in the sequence. Archiving. Each archived log file is named internally and often externally with its log sequence number. It is used in DataGuard or application. The log sequence number keeps standby databases in sync with the primary. Monitoring log activity. DBAs use it to track how fast redo log switches are happening, which can indicate workload or tuning issues. Now, how do you get the log sequence number? You can use the VDollar log. The thread number is nothing but your log sequence number. The sequence number is nothing but your log sequence number. Or you can use the VDollar archive log as well. So you can use the log sequence number from the VDollar archive log, or you can use the VDollar log history to get the last log switch. So this is the log sequence number. Now, let's understand the user managed backup and RMAN backup. I have not covered any questions on user managed backup, but only one question. What is the difference between RMAN and a traditional hot backup? RMAN is faster, can do incremental, and does not place table spaces into hot backup mode. If you want to take the user managed backup, you have to use alter database begin backup, copy files by using operating system commands, and then and backup by alter database and backup. So you have to place, when you take the backup using RMAN, you don't have to do this. You don't have to place your database in the begin backup mode or end backup mode. You don't have to do this. Only when you are trying to take the traditional user managed hot backup, then you have to place the database in the begin backup mode. Now, does Oracle write to data files in begin or hot backup mode? Oracle will stop updating the file headers but will continue to write data to database files even if the table space is in the backup mode. This is very important. Normally, only deltas are logged to redo logs. In backup mode, Oracle will write out complete change blocks to redo log files. This is done to enable reconstruction of a block if only half of it was backed up, split blocks. Because of this, one should notice increased log activity and archiving during online backup. So if you are trying to take user managed hot backups, that time you will find that more redo is generated during hot backup. This answers. So if somebody asks you why more redo is generated during hot backup, because it will not only write the deltas, it will write full blocks into the redo log files. How can you schedule RMAN backups? Using cron jobs in Linux, using DBMS Cellular, or using Oracle Enterprise Manager. So these are some of the tools where you can schedule your RMAN backups. Now let's go through some of the scenario based questions. We have done a lot of theory. Let's see the scenario based situation. So if you want to restore and recover full database, you will say startup no mount. You will first restore your SP file, then you will shut down your database again. You will start up the database using no mount. Then you will restore control file. Then you will put the database in mount mode. Then you will restore your database, recover your database, and you will use alter database open reset logs mode. So this is how you will restore and recover full database. If your one data file is lost, so let's say a single data file is accidentally deleted, the database is still running. How will you do that? You can alter database, you can mark that database as offline, you can restore that particular data file, you can recover that particular data file, and then you can alter database data file online. So database can remain open during this recovery if the file is not system critical. Remember, if the data file that has been deleted is not a critical data file, then your database can remain open. Just give me a minute. So we have covered the data file lost. So remember that you can only do this. You can only do this if the data file which is lost is non-system critical. If you have lost a data file and no backup exists, so let's say you have lost one data file and DB is running in archive log mode, and you have a full database backup of 1 week or a day old and don't have backup of this newly created database, how do you restore or recover? You can use alter database create data file command. So you can create that particular data file and you can recover that particular data file. So you can create the data file and recover that particular data file. If you have deleted archive log by mistake, if logs were not backed up or archive logs were deleted, recovery to the latest point is not possible. Perform incomplete recovery up to the last available archive log. So you will have to set until time based on how much logs you have. You have to set the until time, and then you have to do the perform the incomplete recovery. So if archive logs have been deleted, there is no possibility of recovering your database to point in time. Always advised to never manually delete archive logs. Use delete archive log all backed up one times to device disk. So this one will delete all the archive logs which are backed up at least one times. So use this kind of commands to make sure. So never delete your archive logs. Recover a drop table. So if a user accidentally drops a critical table at 11:30, you are informed at 12 a.m. So recover the database to, sorry, this is actually timing is slightly off here. So basically a user drops a critical table at 12. So and you are informed at, so forget about this. So just, if our user has, don't worry about the timing. So if your user has dropped a table and you are been informed, then you can do a point in time recovery to a minute before the user has dropped. So let's say user dropped a table at 12, then you can go at 11:59, which will basically recover the drop table. Now remember, if only one table is dropped, use table space point in time recovery or flashback if enabled. There are other methods of recovering a dropped table. Now, control file corruption or all control file lost. So if you have lost, if the control files are corrupted or all control files are lost, and if control file auto backup exists, then you can do something like this. You can set the DB ID, then you can start up the no mount, then you can say restore control file from auto backup, then you can mount the database, recover the database, open database in reset logs mode. The control file, since you have recovered the control file, you have to open the database in the reset logs mode. Remember, RMAN automatically searches the control file based on DB ID. That's why you will set the DB ID. You can also use control file backup name. So if you can't search it by the DB ID, you can say restore control file from and control file backup. You can give the control file backup name and you can use that particular command to restore the control file backup. Now, restore database without recovery catalog. Let's say recovery catalog is lost, but you need to restore and recover the database. RMAN maintains metadata in the control file. As long as backups are recorded in the control file and not overwritten, recovery is possible. So list backup, restore database, recover database. Enable control file. So for this reason, you should always enable the control file auto backup to avoid this issue using configure control file auto backup on. Restore only SP file. SP file is corrupted and database won't start up. So start your database in the no mount mode and restore SP file from auto backup. You have to start your database in the no mount mode. You have to start a dummy database or something like that. So you have to just create a dummy instance and then you have to use restore SP file from auto backup. Now, storage crash, restore on a new host. So let's say the database host completely crashes. You are restoring everything on a new server using backups. So approach, install Oracle and match environments such as Oracle Home, Oracle SID. Use control file auto backup. So set the DB ID, start the database in no mount. First, restore the control file, then mount the database, then restore the database, recover the database, open the database in reset logs mode. So we have covered almost all of the questions. This is the end of the tutorial. I know there were so many questions that we have covered. And again, thank you for watching. If you did like the video that I have uploaded, if you did like you can see, if you do like the content that I have uploaded to my channel, do subscribe to my channel. Thank you and see you in next tutorial. Till then, bye bye.